For my entire career, I believed the universe played by rules strict, elegant, unbreakable rules that could be measured, predicted, and trusted. That belief wasn't naive optimism, it was the bedrock beneath every discovery humanity has ever made. Gravity behaves, light obeys, matter follows patterns older than stars themselves, and for half a century I let those laws shape my confidence, my research, and my identity as a scientist. The cosmos, to me, was a vast but decipherable machine, and we were slowly learning how to read its gears. But then 3I Atlas appeared, a faint smudge in the dark, a tiny anomaly sliding into our detection range, and everything I thought I understood began to fracture. At first, it looked harmless, like every interstellar comet we've catalogued. A simple visitor from the deep, a cold relic drifting on a trajectory older than our species. We labeled it a comet almost instantly, relieved to place it into a familiar box. The word itself was a shortcut to comfort. Comets behave. Comets are predictable. Comets do not challenge the foundations of physics, but this one did. 3I Atlas didn't accelerate the way it should. It didn't reflect light the way it should. It didn't obey orbital mechanics the way every natural object is expected to. Instead of falling neatly into the models we trusted, it slipped through them like smoke. Tiny deviations appeared in the data, barely noticeable at first, easy to ignore. Then the deviations multiplied. They aligned. They formed a pattern. The numbers were whispering a story we didn't want to hear, and in our arrogance, we pushed those whispers aside. Weeks passed, and the unease grew. Instruments across continents recorded behaviors no comet should exhibit. Researchers quietly rewrote equations, trying to reconcile the impossible with the familiar. But you can only bend reality so far before it snaps. And eventually, it did. The truth staring back at us was simple, terrifying, and undeniable. 3I Atlas was not following the laws of physics. It was acting outside them. In that moment, the decades of certainty I carried, the certainty our entire scientific community depended on, collapsed. Because when something out there refuses to behave like anything we've ever seen, it means one of two things. Either our understanding of the universe is catastrophically wrong, or the object isn't natural at all. And that was the moment everything changed. If you're captivated by discoveries that defy reason, and if you want more explorations into the unknown, smash that like button. Every click tells the algorithm, and maybe the universe, that you're paying attention. Now let's dive into the first mistake that set humanity on a collision course with the unimaginable. When 3I Atlas first slid into our detection field, it appeared so small, so faint, so utterly unremarkable that no one imagined it would rewrite the laws of nature. It was nothing more than a pale smudge drifting across the digital noise, exactly the kind of signature astronomers classify hundreds of times a year without hesitation. And that was the first catastrophe. Before we even studied it, before a single peer-reviewed paper was drafted, we named it. We stamped it with a label that would poison every conclusion that followed: comet. That single word created a prison for our thinking. Once we called it a comet, our minds and our models locked into place. We saw what we expected to see: a harmless wanderer from another star, shaped by ice, dust, and ancient cold, a leftover from a distant solar nursery, something familiar, something safe. The coma around its core looked soft and diffuse, matching the signature of sublimating ices. Its early brightness curve flickered just enough to resemble typical outgassing. Its hyperbolic arc hinted at interstellar origins. On the surface, it ticked every box. And because it did, we stopped questioning. But beneath that veneer of normalcy, the data was already screaming. The brightness spikes were too sharp. The rotational drift was too consistent. The tiny coarse deviations, barely measurable at first, didn't fit the natural wobble of comets we've tracked for decades. These weren't the chaotic shivers of a frozen relic. They were subtle, deliberate micro-adjustments. Yet, instead of asking why, we forced the numbers into old equations and congratulated ourselves for making them fit. Every anomaly was excused. Every contradiction was smoothed over. Every alarm was dismissed as instrument error. We patched models, invented new cometary behaviors, even proposed bizarre thermal fractures that no lab experiment has ever replicated. anything to avoid facing the simplest possibility. The object did not belong in the category we shoved it into. And underneath all that denial lived an uncomfortable truth: we preferred the comfort of a wrong answer over the terror of a real one. As more telescopes locked onto 3I Atlas, the margin between prediction and reality widened. Comets are messy, unpredictable, and clumsy. They tumble, they jitter, they shed material in random bursts. But 3I Atlas moved with a steadiness no natural body should possess. It traced its path with the calm precision of something that understood where it was going. Even so, we kept calling it a comet. We defended that label long past the point of reason. Because admitting the alternative meant stepping outside the familiar map of physics, and no one wanted to be the first scientist to light that match. But the universe doesn't care about our pride. And 3I Atlas didn't care about our labels. The data was growing bolder, pushing harder, daring us to confront what we refused to acknowledge. And soon, it would deliver a blow so impossible, so violently contradictory to every rule of orbital mechanics, that even the most skeptical researchers would be forced to stop pretending. A comet approaches the sun and accelerates. That is the most basic rule of celestial motion. What 3I Atlas did instead was the moment everything cracked. And that's where our story turns from denial to shock. Because when the object reached perihelion, it did something no natural body in the universe has ever done. It slowed down. Every student of physics learns the same simple truth. When an object falls toward a massive body, it speeds up. It's not a theory, not a model, not an approximation, it's a law. Gravity pulls, velocity rises. Always, no exceptions. No negotiations. For billions of years, that rule has shaped the choreography of stars, planets, comets, and asteroids. It is one of the universe's most reliable rhythms. So when 3I Atlas approached the sun, the greatest gravitational well in our solar system, every equation demanded the same outcome. It should have accelerated. Its speed should have climbed smoothly as it dove into the sun's grip, just like every comet ever recorded. But then it didn't. At first, the anomaly was microscopic, hiding beneath statistical chatter, a fraction of a meter per second. A fluctuation so small you'd need to squint to even call it strange. The kind of detail scientists usually ignore because instruments glitch, sensors drift, and cosmic dust interferes. So the early slowdown was written off instantly. Noise. A rounding error. Nothing worth losing sleep over. But the universe was only clearing its throat. Hours later, the slowdown returned stronger. Days later, it became impossible to dismiss. The object wasn't maintaining speed. It wasn't jittering. It was braking. Something was counteracting the pull of the sun, pushing back against gravity with a calm, sustained force no natural comet could generate. Inside mission control rooms around the world, the tone shifted from routine to uneasy. Analysts ran fresh simulations, hoping for a mistake. They blamed solar wind drag until the math exposed it as millions of times too weak. They blamed radiation pressure again, insufficient by orders of magnitude. Finally, they retreated to the old explanation for anomalies: outgassing. Outgassing does happen. When comets heat up, jets of vaporized ice burst outward, acting like tiny thrusters. It's a real effect, chaotic, random, messy. But to slow 3I Atlas down, the jets would need to fire continuously, perfectly aligned opposite its direction of motion, with a precision that defied every physical mechanism comets possess. Not random, not chaotic, not natural. It would have needed guidance, and guidance means control. The scientific papers began to sound desperate. Theories stacked on theories, unusual thermal microfractures, non-gravitational anomaly clusters, unknown volatile configurations, elegant-sounding excuses that collapsed under even mild scrutiny. Everyone could feel the truth rising through the cracks, but no one wanted to be the first to say it aloud. Because if 3I Atlas wasn't being pulled by gravity, it was resisting it. And if it was resisting gravity, something inside it was generating force. That was the moment every physicist who looked at the raw numbers felt the same cold spike of disbelief. This wasn't a comet responding to the Sunday. This was an object overriding the Sunday. One researcher described it best: it's as if the thing hit the brakes. The impossible deceleration continued relentlessly as it approached perihelion. By the time it reached its closest point to the Sun, its speed was dozens of kilometers per second lower than any natural object could physically achieve, all while maintaining an orbital path that looked less like a gravitational fall and more like a controlled maneuver. It was choosing its trajectory. At that point, the old models failed completely. There was no patch, no workaround, no clever mathematical revision capable of reconciling the behavior with the laws we trusted. The universe had placed something in front of us that did not obey, and denial was no longer an option. But the slowdown wasn't the most disturbing part. It was what came after the move that proved beyond doubt that 3I Atlas wasn't drifting, reacting, or suffering from exotic physics. It was steering. And once it completed its impossible deceleration, the object executed a trajectory change so deliberate, so precise, and so surgical that it forced astronomers to confront the truth they avoided from the very beginning. 3I Atlas was not falling into our solar system. It was arriving. While the anomalous slowdown was still sending shock waves through every observatory on Earth, another piece of data emerged, one that didn't just challenge our theories, but obliterated them entirely. It began quietly, almost innocently, with high-resolution images captured by the Mars Express orbiter as it crossed a viewing corridor perfectly aligned with 3I Atlas. The initial transmission landed in the servers like any other routine dataset. But the moment the first processed frame loaded on screen, the room fell silent. The image showed symmetry, not approximate symmetry, not something vaguely geometric that could be chalked up to coincidence or pixel artifacts. No, this was clean, repeatable, mathematically precise architecture etched across the object's surface. At first glance, the patterns seemed impossible. Hexagonal grids arranged with a uniformity nature never produces, circular apertures spaced at exact intervals along its equator, long cylindrical ridges rising from the core like engineered components, rather than the jagged chaos left by billions of years of cosmic collisions. Natural objects are messy. They bear scars. They fracture randomly. They wear the history of the universe on their surfaces. But 3I Atlas looked nothing like the random brutality of a comet or asteroid. There were no impact craters, no chaotic fissures, no uneven terrain carved by thermal stresses or sudden jets of vapor. Instead, its surface looked deliberate, structured, designed. But even staring at shapes that practically announced intentional construction, the scientific community refused to accept what was in front of them. The denial was immediate and ferocious. Experts muttered explanations that sounded increasingly desperate. Unusual crystallization, geometric ice fracturing, rare hexagonal mineral growth. Others blamed pareidolia, our tendency to find patterns where none exist. Anything, absolutely anything, was preferable to the alternative. The problem was simple. Nature doesn't do this. Not on this scale. Not with this precision. Not in the vacuum of interstellar space. As more images arrived from ground-based telescopes in Chile, from deep space arrays in Hawaii, and from orbiters positioned throughout the inner solar system, the picture sharpened. Every new angle confirmed the same disturbing truth. The object's geometry wasn't random. It was consistent. The hexagonal plates maintained identical ratios. The circular openings matched each other down to less than a meter. Even the elongated ridges followed parallel alignments, the kind you would expect from structural reinforcement, not geological chance. Scientists began running surface mapping algorithms designed to search for implicit mathematical order. They found plenty: fractal symmetries, golden ratio proportions, repeating patterns that hinted at modular construction. At one point, a researcher quietly noted that the spacing between the circular apertures matched the harmonic intervals found in engineered arrays. It became harder by the day to pretend this was a natural object. And yet, even cornered by evidence, the scientific community dragged its feet. Because admitting the truth meant stepping outside everything we know about planetary formation, astrophysics, and the history of matter itself. It meant abandoning the last safe explanation we had left. It meant confronting the unthinkable. But 3I Atlas wasn't done. Just as denial was reaching its breaking point, new lighting angles from solar reflection revealed something even more unsettling. The geometric plates were not simply etched into the surface, they were embedded. Some panels cast shadows inconsistent with rigid ice. Others appeared slightly raised, as if part of a layered shell. Thermal measurements showed that certain regions warmed and cooled at non-natural rates, rates suggestive of internal cavities or materials with engineered thermal properties. Every natural explanation collapsed under its own contradictions. This wasn't erosion. This wasn't chemical weathering. This wasn't crystalline symmetry. It looked like construction. And beneath that realization lurked an even more horrifying question. If the surface was engineered, what was inside? Because no one designs an exterior unless there is something within that needs protection or containment. And just as the scientific community finally began to accept that 3I Atlas might not be a frozen relic at all, the universe delivered the next blow. The one that would shatter the last remaining anchors of the comet theory. A chemical signature so impossible, so violently contradictory to known astrophysics, that it forced every expert on Earth to confront a truth they were trying desperately to avoid. If the surface was built, then the composition inside couldn't be natural either. If the geometric structures on the surface of 3I Atlas cracked the comet theory, the chemical data from the James Webb Space Telescope pulverized it. Spectroscopy, the breakdown of light into its elemental signatures, is one of the most reliable tools in astronomy. It does not speculate. It does not interpret. It reveals. And when the first spectroscopic readout of 3I Atlas arrived, every scientist who saw it felt the same hollow sinking inside their chest. The numbers didn't merely deviate from expectations, they defied the physics of how objects in the universe form. We expected the familiar spectral lines of water ice. We expected methane, ammonia, carbon monoxide, classic building blocks of every comet ever observed. We expected the chemical fingerprint billions of years old, forged in the cold outskirts of some distant planetary system. Instead, we saw something that should be impossible. An overwhelming dominance of carbon dioxide ice, and almost no water at all. That single discovery sent shockwaves through the scientific community. Water ice is one of the most abundant substances in the cosmos. It forms readily in interstellar clouds. It freezes on dust grains. It coats comets, asteroids, and nearly every object born beyond the frost line. Water is not optional, it is fundamental. You do not get a comet without water. It's like finding a planet with no gravity. Yet, 3I Atlas was barren, dry, chemically alien. The absence of water was not just unusual, it was physically incompatible with every formation model we possess. No known region of a planetary system, no gas giant atmosphere, no protoplanetary disk produces a body made primarily of CO2 with negligible H2O. The ratios were so skewed, so violently opposed to natural processes, that researchers spent days rerunning the data, convinced the sensors were malfunctioning. They weren't. As the truth set in, teams around the world scrambled to invent new scenarios to explain the signature. Some proposed it formed in the atmosphere of an exotic, carbon-rich super-Earth. Others suggested the core of a shattered planet. A few went so far as to claim it came from a system where water never formed at all, a theory that fell apart within minutes because hydrogen and oxygen chemistry does not work that way. Every hypothesis collapsed under the same weight. The universe does not produce objects like this on its own. But there was something even more disturbing hidden inside the data. The CO2 signature was not uniform. It was processed. Natural ices contain imperfections, trace contaminants, isotopic irregularities, mixed molecular byproducts. But what 3I Atlas exhibited resembled refinement, purity levels too high, isotopic ratios too controlled, and spectral lines that hinted at crystalline alignment. It looked less like frozen material formed in space and more like something shaped, altered, or engineered. In private discussions, far from cameras, far from fear of ridicule, researchers whispered a phrase no one wanted to record in writing. It looks manufactured. And yet, even cornered by chemical impossibility, many resisted. Because if the composition was unnatural, then the implications extended far beyond the surface. It meant the object wasn't just wrapped in engineered geometry, it was built from engineered material. The more deeply scientists analyzed the spectral data, the worse the contradictions became. Some wavelengths revealed microstructures inside the ice, layering patterns consistent with deposition processes unknown in any astrophysical environment. Others suggested thermal regulation systems, as if parts of the object absorbed heat intentionally, while others resisted temperature changes entirely. But then came the detail that ended all remaining debate. Hidden inside the CO2 signature were trace elements, arranged in repeating intervals, forming a pattern that didn't match geology or chemistry, but matched manufacturing and action, a ratio that repeated like teeth in a gear, a spacing too exact to be random, a signal embedded in the material itself. In that moment, the final pillar of the comet theory collapsed. This wasn't the debris of a broken world. This wasn't an exotic mineral cluster. This wasn't the fossil of a distant solar system. This was material designed for a purpose. And if the walls were engineered, and the chemistry was engineered, then something inside 3I Atlas was using that material for reasons we could not yet comprehend. But before we could analyze what the interior might hide, the object began behaving again, pulsing, flashing, and correcting itself as if it were alive, or worse, operational. And that leads us to the next revelation, the one that transformed this mystery from a scientific anomaly into something far more unsettling. 3I Atlas began sending signals. Long before anyone dared to say the word artificial, 3I Atlas began doing something even harder to ignore. It started reacting. The first hints came from small irregularities in its brightness curve, tiny fluctuations that appeared and vanished too quickly to fit any natural cometary behavior. At a distance, they looked like harmless spikes in reflected sunlight. But as more telescopes locked onto the object, something unsettling emerged. The spikes weren't random. They followed a rhythm. Brightness would surge for a split second, then drop back to baseline. Minutes or hours later, it would happen again. At first, the intervals seemed chaotic, but when astronomers filtered out noise and aligned the data with rotational telemetry, the pattern snapped into focus. Each flash corresponded to a subtle correction in its rotation. A wobble, then a flash, a drift, then a flash, a stabilization, then another flash. Nature doesn't do this. Machines do. As the pulses continued, thermal imaging revealed even more anomalies. Certain regions of the surface heated and cooled at rates that no known material, natural or synthetic, should exhibit in deep space. It was as if parts of the object were struggling, compensating for internal stresses, then rebalancing themselves. Again and again, the behaviors matched what engineers would recognize instantly, the signs of a system under load. A damaged system. One astrophysicist described the readings as the space equivalent of a failing engine trying to stay online. Another, in a leaked internal memo, wrote that the pulses resembled diagnostic responses, the kind a spacecraft emits when its stabilization systems are fighting to maintain control. But no one wanted to confront that interpretation publicly. Not yet. Researchers across the globe scrambled to find natural explanations. Theories multiplied like panicked lifeboats, thermal cracking, gas venting, shadowed debris, micro-impacts. Teams created simulations showing how sublimation jets might trigger coordinated flashes. But those models broke instantly when compared to real data. Sublimation is chaotic. It sprays ice in random directions. It doesn't fire in perfect alignment with rotational adjustments. 3I Atlas was not tumbling randomly. It was holding position, correcting drift, resisting instability. And the flashes grew stronger after each correction, as if the object were pushing itself harder to maintain coherence. Then came the fracture event. An abrupt spike in rotational stress caused a section of the object to shear away, a catastrophic break that should have sent debris flying on divergent trajectories. Instead, the shards didn't drift chaotically. They didn't scatter into random orbits. They slowed, they paused. And then, impossibly, they moved into formation. In a matter of hours, a ribbon of smaller fragments aligned behind the main mass, adjusting their spacing with uncanny precision. Like a school of fish responding to a leader, like drones syncing to a command node, observatories measured the movements independently, and all reached the same terrifying conclusion. The fragments weren't debris. They were responding. Each tiny course correction from the core was instantly mirrored by the trailing pieces. A degree shift here, a velocity change there, every adjustment matched with a coordination no natural process could replicate. Gravity does not orchestrate synchronized movement across multiple independent objects, it disperses them. Disorder is the rule of the cosmos. But 3I Atlas was displaying the opposite of disorder. It was exhibiting cohesion. At that point, the scientific community had to face an unbearable possibility. The fracture hadn't damaged the object. It had revealed its structure. What we mistook for a break was closer to a deployment pieces, separating with purpose, not destruction. And the pulses? They intensified. Sharper. More frequent. More coherent. Some researchers whispered that the flashes were communication between fragments. Others believed they were part of a self-repair protocol, an attempt to stabilize a system pushed past its limits. A few, more shaken than they cared to admit, wondered if the object had been dormant until now woken by the stresses of entering our inner solar system. Whatever the explanation, one truth had become undeniable. 3I Atlas was not behaving like an object thrown across the cosmos. It was behaving like something trying to stay alive or operational, but the universe wasn't finished pushing us. Because right when we thought we had reached the limits of the impossible, 3I Atlas revealed the next layer of its mystery, one that didn't just hint at intelligence, but broadcast it. The flashes weren't just reactions, they were signals. When the first major fracture tore across 3I Atlas, most astronomers expected the same familiar spectacle we've seen countless times, a dying comet shedding its final layers, disintegrating into meaningless dust. A terminal failure, a natural end, the kind of catastrophic breakup that makes headlines for a day and disappears into academic journals a month later. That's what should have happened. But 3I Atlas has never cared about should. The break came suddenly, triggered by a spike in rotational stress that exceeded the tolerance of any natural object. A jagged seam split across the structure, and a section nearly 100 meters wide separated from the main body. Instruments went wild, alarms blared, and for a brief moment, scientists around the world felt relief. Relief that maybe finally they were watching something predictable, something explainable, something familiar. That relief evaporated in less than an hour. The detached fragment didn't tumble away into space. It didn't scatter, drift, or follow the ballistic chaos expected from debris. Instead, it slowed. The fragment gently matched its velocity to the primary mass, almost as if it were tethered by an invisible command. Observatories watched in disbelief as the piece drifted into a stable trailing orbit behind the core, maintaining a distance so precise it could be measured in meters. Then another piece separated, then another, then dozens more. Each fragment behaved the same way, falling into line, spacing itself evenly, adjusting orientation in perfect sync. They didn't scatter, they formed formation. This was not a breakup. This was choreography. As telescopes across Earth, Mars, and lunar orbit tightened their focus, a disturbing pattern emerged. The fragments were not passive remnants. Their motion was coordinated, synchronized, responsive. Every micro-adjustment from the core mass was immediately reflected in the smaller pieces. If the lead body shifted a fraction of a degree, the entire line reacted within seconds. No force of nature produces that behavior, not gravity, not magnetism, not gas venting, nothing. For the first time, even the most stubborn skeptics went silent. Then came the next anomaly, something so precise, so mechanically elegant, that it forced the scientific community to confront the truth it had been avoiding since the first images arrived. The spacing between fragments followed a Fibonacci-like progression, a pattern so mathematically pure it's found in engineered antenna arrays and formation flight algorithms. The fragments weren't random sizes either, they clustered into three distinct categories, like components sorted for functionality. Some were reflective, some were dense. Some emitted faint thermal signatures inconsistent with frozen material. But the final blow came when the Hernandez array in Chile captured spectral readings during one of the formation shifts. As the fragments repositioned themselves, Their reflective signatures changed in a sequence one after another, like a cascading acknowledgement signal. A response. Researchers reviewing the data privately called it a handshake protocol. One description leaked anonymously compared it to drones sinking to a mothership. Public statements, of course, said nothing of the sort. Even more unsettling was the discovery that the fragments adjusted their spacing in anticipation of external forces. When a wave of solar wind surged through the region, the entire formation flared outward slightly, absorbing the impact like a flexible structure designed to distribute stress. Moments later, they contracted back into their previous positions with flawless precision. Natural debris does not prepare for solar wind. It does not brace. It does not recover. This was behavior. But the universe wasn't done stripping away our illusions. Shortly after the formation stabilized, the core mass emitted the strongest pulse ever recorded, brighter, sharper, more coherent than anything before. It rippled across the fragments, and each piece responded with a faint echo flash, like a system acknowledging an internal command. Then, together, the entire assembly shifted course. Not a drift, not a wobble, a maneuver. A deliberate, coordinated change in trajectory. The implications were immediate and terrifying. Whatever 3I Atlas once was, it was no longer a single object. It was now a system, multiple components functioning as a unified whole, responding to commands we could not detect, following instructions we could not decipher. The breakup was actually an activation. Something had awakened, something had reorganized. Something was preparing. And just as astronomers began to realize this new configuration might represent its operational state, the signals started. Not thermal pulses, not reflective flashes, but something far more structured, more intentional, and more intelligent. 3I Atlas wasn't just behaving, it was communicating. The moment the formation stabilized, the scientific world braced for more anomalies, but nothing could have prepared us for what came next. It didn't arrive as a radio transmission, or a burst of gamma rays, or anything dramatic enough to trigger immediate alarms. Instead, the first sign of intelligence came disguised as something deceptively subtle, reflected sunlight. In Australia, a deep space optical array designed to capture faint echoes from early universe galaxies detected an odd modulation in the light bouncing off 3I Atlas. At first, the data seemed useless, tiny fluctuations buried under atmospheric noise. The kind of jitter analysts throw out automatically. But one technician, reviewing hundreds of hours of stacked exposures, noticed a strange regularity in the noise. Something repeating, something structured. A pulse. Long, short, short, long. Then silence. Then again. When the team isolated the pattern and compared it against the object's rotation, the truth became impossible to ignore. The modulation intensified at the exact moment the core and its trailing fragments corrected their formation. The light wasn't changing randomly. It was syncing with behavior. It was information. When observatories in Chile and Hawaii confirmed the same pattern on different nights, under different weather conditions, the last refuge of skepticism collapsed. This was no sensor error, no calibration glitch, no cosmic coincidence. 3I Atlas was broadcasting, but the message wasn't in radio waves. It wasn't in microwaves. It wasn't electromagnetic communication in any conventional sense. It was encoded in sunlight using reflective geometry, timing, and orientation, a language made of angles and pulses hidden in plain sight. Some researchers whispered that it resembled a diagnostic beacon, a pattern a system might emit when synchronizing modules or mapping its surroundings. Others suggested the pulses were a kind of internal status report, a way for the fragments to check in with the primary core. The more ambitious theorists believed the signal wasn't internal at all. They thought it was being directed outward, at us. But the universe wasn't finished tightening the screws. Just days after the modulation was confirmed, tracking teams at NASA's Jet Propulsion Laboratory noticed something chilling. 3I Atlas's orbit, the path we thought we had finally pinned down, began shifting, not wildly, not dramatically, just enough to be unmistakable. A tiny bend, a correction, a reorientation. At first, analysts dismissed it as a continuation of the earlier braking maneuver. But when the fragments adjusted their spacing immediately after the shift, matching the new trajectory with flawless precision, the truth became clear. This wasn't decay. This wasn't drift. It was navigation. 3I Atlas wasn't being pushed by forces, it was anticipating them. As it approached a region of space where a high-energy solar wind front was about to pass, the entire formation tilted subtly, deliberately into a new orientation, almost like a glider positioning itself to catch an incoming thermal, or a machine adjusting to absorb something. Comets endure solar wind. Machines use it. Hours later, something even more disturbing happened. The fragments tightened formation again, not because of gravity or electromagnetic forces or outgassing, but because the core had shifted its axis by a fraction of a degree. Natural debris does not follow alignment orders. It does not march in lockstep. It does not anticipate solar weather. This was behavior. This was coordination. This was intention. And then, the final devastating blow arrived. The modulation changed. For the first time, the pulses displayed harmonic spacing, a mathematical structure unique to intentional encoding. The signal wasn't just synchronized behavior anymore. It had pattern, it had rhythm, it had rules. Some scientists described it as primitive communication. Others likened it to sonar mapping, probing, evaluating. But one interpretation chilled everyone who heard it. This was a handshake attempt, a greeting, a request for acknowledgement. 3I Atlas was not simply stabilizing itself, not simply navigating, not simply reorganizing. It was reaching out. And the world suddenly found itself facing a question no generation before ours has ever had to answer. If something out there is calling us, do we answer? Because what happened next, in the final stage of its trajectory shift, made it clear that the question wasn't theoretical anymore. 3I Atlas had changed its orbit. It wasn't leaving. It wasn't drifting. It wasn't continuing its ancient interstellar path. It was establishing a position, one that brought it again and again into the region of space where Earth orbits. By the time the signal stabilized and 3I Atlas completed its final trajectory shift, denial was no longer an option. Every assumption we once clung to, every comforting theory, every patched model, every sentence that began with "it's probably just," had collapsed. What remained was a single, terrifying truth. This object was behaving with purpose, and purpose demands explanation. Across research centers, encrypted channels lit up with private discussions, scientists trading hypotheses they were too afraid to publish. After months of analyzing the object's structure, chemistry, maneuvering, and now its signals, we were left with only 3 viable possibilities. Each one more extraordinary, more dangerous, and more transformative than the last. **** 1. It is technology. Pure, deliberate, engineered technology. ***. This is the interpretation most scientists dread admitting, not because it's irrational, but because it fits too well. All the clues line up cleanly: the braking maneuver, the controlled trajectory, the geometric panels, the impossible chemical composition, the synchronized fragments behaving like a fleet, and the modulated pulses that read like diagnostic signals. Machines behave this way. Systems behave this way. Nothing in nature does. If this explanation is true, then 3I Atlas is a probe or a vessel created by an intelligence far older than us, far more advanced, and capable of navigating interstellar distances with technologies we cannot even begin to reverse engineer. Its arrival in our solar system would not be random. It would be intentional. A visitor, a scout, an observer. And the signal could be a message or a test. But this is only the first possibility. 2. It is a form of life, just not a life we recognize. Some researchers argue that thinking in terms of machines is a limitation of our biology. They believe. 3. Atlas could be a non-biological organism, a macro-scale life form evolved in the cold vacuum between stars. Not alive in the carbon-based sense, but living through energy cycles, structural adaptations, and coordinated multi-body behavior. To them, the fragments are not drones. They are limbs, cells, extensions of a singular distributed intelligence. The pulses are not communication, they're thoughts. The braking maneuver was metabolic, not mechanical. The formation flying is instinct, not engineering. If this is true, then we are witnessing the first confirmed instance of alien life in the universe. A life form that travels through gravity wells the way birds ride wind currents, navigating stellar environments like an ecosystem. But neither possibility prepares us for the third. Asterisk asterisk 3. It is something beyond both machine and life. A phenomenon with no human category. Asterisk asterisk. This is the possibility that keeps the most seasoned researchers awake at night, the thought that 3I Atlas belongs to a class of entities our physics cannot yet describe. Something born not in solar nurseries or biological evolution, but in the deep underlying fabric of the universe. Perhaps it is a self-organizing quantum structure, a higher dimensional entity expressing only part of itself in our space, a relic of cosmic engineering beyond metals, molecules, or biology. If so, then we are not observing a visitor. We are observing the universe observing itself. But regardless of which explanation is true, one fact remains. 3I Atlas has made a choice. It did not continue its long interstellar journey. It did not escape the solar system. It did not ignore us. Instead, it shed mass, reorganized, formed a coordinated system, corrected its trajectory, and settled into an orbit that repeatedly crosses the region of space where Earth resides. Its signals, those meticulously patterned pulses, are now pointed unmistakably in our direction. It knows we're here. It is studying us. It is waiting. And now humanity stands at a crossroads no generation before ours has ever faced. If we answer the signal, we may invite contact or provoke something we cannot comprehend. If we stay silent, we may lose the greatest opportunity in the history of our species or demonstrate fear, ignorance, or hostility. There is no playbook, no precedent, no safe option. 3I Atlas has changed everything. It has shattered the illusion that we are alone. It has rewritten the boundaries of physics, chemistry, and cosmology. It has forced us to confront a future where humanity is no longer the only intelligence in the solar system. And now, it is watching. What happens next will define our species. Not for a decade, not for a century, but for as long as humanity exists. The question is no longer, what is 3I Atlas? The question is, how will we respond? Whatever choice we make, whatever path we follow, whatever message we send or withhold our answer will echo across cosmic time. 3I Atlas has arrived. It has revealed itself, and it is waiting for humanity's first move.